Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. In today's video, I want us to look at a topic that is specifically for grade 12s, right? So it is now called functions as well as their inverse, right? Now, their inverse now, it is when now we have a function that it is rotated in any way or whatever that it is done to it, such that now we obtain a new graph, right? Yes, the basic theory does not matter. I'll tell you the most important parts, right? Now, we need, before we go into this topic now, be in a position of understanding exactly what do we mean when we say a graph, it is a function, right? Can you hear? A graph is a function. So we have many graphs, right? But not all graphs that we encounter or we see are necessarily functions, right? So now let's be in a position of understanding exactly what are functions. What is a function, rather? So a function, it is a relation, okay? It is a relation where each values in the domain, I wrote the x values, is associated now with only one value of the range. What does this mean in simple terms? Because now I see many English words now. It says now a function, to consider a graph as a function now, you need now to have a graph such that now when I input values of x, one value of x, maybe I get only one value of y, right? Or now when I input many values of x or two values of x, as long as I get only one value of y, that is what we consider as a function, okay? So hence now it says a relation where each values in the domain x values, okay, here we said values kabomu because now it can be many values, but now it should be associated with only one value of the range. What do I mean? It means now when I have a graph, it should be in a way such that when I insert now, okay, when I insert now whatever values of, let's say this is a graph f of x, whatever, if I insert values of x here, okay, remember these are x, these are y, whatever values of x that I insert into my function, they give me a specific value of y, and it only produces one value of y, okay. That's what we refer to as a function. Can you see I inserted these three values into this function? Then I got what? One value of y. So that is what we mean by now what we consider as a function. Let's now look into more details about now the mapping of the graph. The mapping of the graph, you can have a one-to-one graph. A one-to-one graph, it is a function. Why? Because now it produces, remember, it is x to y here, right? So now this is a function. Why? Because now can you see it gives us one outcome of what? Of y value, okay? Remember, if we get one value of y, then that is what we consider as a function. Then we have also many. This is one to many, then this is many to one. We do not care uh, how many values of x you input. What we are interested in is that at the end of the day, we get what? We get only one value of y, right? Here we have one to many. Is this a function? No. Why? This is a function. Why is this a function? Because now we have many values of y, okay? Okay, so that's not what we want. We want a relation such that now for each and every unique values of x, we get a very, very unique y value. All right. Or I can say for each values of x, I get a unique y value. Okay. When it is unique now, it means now it is the only one. Okay. So this is not a what? This is not a function. This is not a function. The one I ticked now, they are functions. This one, many to many. Here, the problem is in the y value. If the y value is many, it is not unique. Therefore, it is not a what? Not a function. How interesting is that? Now, let's be in a position of saying, okay, let us practically understand that. Exactly what do we mean now by functions being a a graph being a function or not, right? Yes. Now, Let us consider, this first, uh, the first graph here. All right. The first graph that we might be in a position of encountering, or now as an example, it is this one. Okay. Let us say, all right, we have a function here. Here is that function, our unique function. Or sorry, not function. We should call it a graph until we have proven it that it is a what? It is a function. So we have now the following graph here, right? Let me take it a little bit here. Good, good. It looks good now. So now we say this is my y, this is my x. Now, the question is now, tell us, okay? Tell us, okay, let me just write out the instruction also. Wait, it's fine. I'll put it here. Okay, let me quickly do those. It says, um, determine, determine whether each graph, can you see whether each graph, we call it a graph because we haven't proven it. Each of the following graphs of the following graphs is a function or not, or or not. Cool. Now, this is on number A. Let me, why do we always leave these? Okay, very good. Let's do this on number A here. Okay. Let us be in a position of saying, all right, we are seeing here is the graph now. The question is this a function? Is this graph a function or not? Okay. Now, what you might do, you might come here and say, okay, let us check now our mapping. Okay. Our mapping. What is our mapping? Our mapping is now for each value of our x here, you can take any value of x. Let's take any value of x there and cross a line like that. Okay. Now, can you see we are using the very same value here of x, right? Which is this one. Okay. Now, let's check how many values of y do we get. Can you see now this x produces this y here? This x also produces this y here. Can you see that? Is this unique? No, it's not unique. Why? Because now it gives us what? Two values of y. This is the first one. This is the second y. So this is not a function. Why? Because now we have two values of y. But now I want you to introduce, instead of using this one, and call it uniquely now and say, okay, be in a position of calling it like this. Have a vertical line test. Have a what? A vertical line test. What exactly is a vertical line test? You take your ruler and say now, okay, okay, let me bring it here. Anywhere on my graph, let me just draw a what? A vertical line test. Anywhere on my graph, just anywhere on my graph, let me just draw a vertical line test. Okay. If that vertical line test touches the graph twice or more than once, let me say, if the graph touches, if that vertical line test touches a graph once, that graph it is a function. But if that vertical line test touches a graph more than once, that graph it is not a what? It is not a function. Let's see how many times does it touch. It touch here. It also touches here. We want to where it touches the circle, not the intercept, right? So can you see it touches here? It also touches here. What does that tell you? This tells you that this is not a function. This is not a what? A function. But you need to say to us, why exactly are you saying it is not a function? Why? Because now a vertical line test touches the what? The graph, the graph, more than once. Okay, more than once. Or now, this is the first one. Or now you can be in a position of saying, instead of using that, I can say now, for every, can you see now, for every x value here, if I choose this x value here, can you see it produces the y value here? It also produces the y value there. So it gives us the mapping what? This has a mapping of what? One value of x. It gives us many values of y. Can you see that? Can you see that? So now you can say, instead of now saying instead of saying vertical line test touches the graph more than once, you can say now the mapping of the graph is 1 to many. And remember, 1 to many, it is not a function. 1 to many is not a function because now we want, as a function, it says now associated with only one value of y. Can you see? If now we get anything that has many values of y, that is not considered to be to be a function. I hope that's clear. It should be clear. All right. Let me now say, okay, let us divide our page into two such that now we are in a position of answering the next question. All right. Yes. Now, let me say, okay, let us divide this into two like that. Okay. Let us consider now again a graph. Okay. And let us consider now a what? A graph. Like maybe a graph like this on number B. A graph like this on number B like that. Quickly do that, draw that graph that I want us to look into. You need to relax when doing this. Just relax and just do a vertical line test. It will tell you everything. Okay. This is our parabola, our unique parabola thereof. Now we want to check now. Okay, is this now a function or it's not? It's not a function. Okay. Now what do? We take our vertical line test. You'll be using a ruler in your exam. Okay. You don't need to draw it on a graph. You can draw it, it's fine. But you use a ruler and draw a dotted lines, okay? And say now, okay, anywhere on my graph, I can draw it here, I can draw it as long as it touches the graph, right? Anywhere on the graph, I can draw it here, anywhere there. I can say when I draw it here, when I draw it there, it touches my graph how many times? Once. Can you see? When it touches my graph once, what do we call that? We say it is a what? It is a function. All right. Let us consider another point so that we do not say here it touches only once. Hey. What if there it touches twice? We can consider any other point again. Here. Okay. What does it do? It touches our graph how many times? Once again. Can you see that? It touches our graph here. Oh, okay. Let me remove this rule. It touches our graph here once when we do this vertical line test. When we do another one, it touches that function there. Okay. You check one vertical line test touches how many times? Not two, saying when I draw two, it touches twice, then it is not a function. No, you check only one vertical line test, then it does what? It touches once, then it is a function. Here, one vertical line test touches how many times? It touches twice. Where? Here and where and there. Therefore, this is not to be considered also what? As a function. Therefore, we're going to say this is a function. Is a what? It is a function. Why are we saying that? Because now the vertical line test test touches. You do not say it touches the function, it touches the graph. Graph exactly once. Okay? Or you can say now the mapping here is what? When I put one value of x here, on whatever value of x here, can you see now I get a unique what? A unique value of y. So this is a what? It is a one-to-one function. Can you see when I just put one value of x anywhere randomly? and do a line like that, then it produces what? One value of y. So we say that it is a what? It is a one-to-one function. So the mapping is 1, 2 to 1. How interesting is that? How interesting is that? A one-to-one function. Now we can call it a function because now we have proven, no, this is not a function. One-to-many is not a function. Okay. Only this one that we prove it is a function, you can say it is a one-to-one. It's a little one-to-one. It is a mapping of one-to-one. Okay. Yes. I want to believe now you are in a position of understanding when we say something, it is a what? It is a, it is a, what is this? A function or not a function? Okay, we can also use a horizontal line test, but now that won't be important, right? Okay, yes, that won't be important. Now, I want us to now check exactly how do we obtain an inverse function. Okay, I want us to see exactly what do we mean when we say something. It is an inverse of a function. Okay. Now, what exactly do we say when we say inverse of a function? We are saying now we need to do what? We need now to reflect this graph now, okay? We need to create a mirror of the original graph such that now the inverse of a function is the symmetry of a graph about the line y is equal to x, okay? Now, if we move from what? From original function, okay, to actually to an inverse function or vice versa, actually going back and forth. When the original function is changed to an inverse function, we need now to reflect whatever that we are changing across the line now, okay? It needs to be a symmetry of a graph. It should be a symmetry across or about, now let me use about the line, symmetry about the line y it is equal to x. What exactly is the line y is equal to x? Now, we want to look at that. Okay, we're going to look at that. Y is equal to x. It is a line that passes exactly through the origin. When I draw my function like this, maybe x is equal to y. It is a line that passes exactly through the origin. So this is what we call, so not x is equal to y. It is equal to x. Okay, yes, it is equal to x. All right. Now one might ask, what will happen if I say x it is equal to y? Well, don't, but I don't think it will be a big deal, but don't. Symmetry about the line y. When we want to move from the original to the inverse, you need to reflect whatever the original function to the across the about the line y is equal to x. Or now, if you want to move from an inverse to an original, you need also to apply the very same thing, y is equal to x, not in reverse, x is equal to y. No. Okay. Yes. Now, the question might come and say to us, how now, how to determine, okay, we need to be in a position of how to determine the inverse of a function. How do we get the inverse of a function? All right, that won't be a difficult part because now you'll see these are very, very, very easy steps that people tend to make mistakes on, right? But now let's try to fix that. The first step that you need to follow, okay, you need to write in standard form, okay? You need to write in standard form. What do I mean now by standard form? A standard form, it is y, it is equal to mx, okay, y is equal to something. Let me put it like this. Y it is equal to, I'm going to triangle smart when. Y it is equal to something. Then this is what we refer to as a standard. We don't care whether here it is x squared minus 1 divided by 4, as long as it is y, it is equal to something. That is what we refer to as a standard form. On number 2, you need to do what? You need to do what? You need now to switch, or actually not switch, swap. Let me use a very, very good English. Swap or interchange x and y. Very, very key. You swap x and y. Here you write in what? Standard form. Okay. The last one, solve and make y the subject of the formula. How interesting is that? Now, let's stop saying how interesting is that, whereas now we do not have a proper example now to say, okay, this is what we mean. Now let's have an example. Okay. Let's have now what we refer to as an example. What is an example that we're going to consider? Okay. Now, let's say our instruction says find the inverse equation of each of the following functions, right? Then we need to know, okay, we know for an inverse it is like this, f of x, okay? But sorry, for original function it is like this. For an inverse, it's gonna be an inverse negative 1x, okay? This is what we refer to as an inverse, not this, not this. This it is the derivative that you deal with on calculus, okay? Not that. So of a function, write, can you see, write them in the form of, okay, it is equal to the of. Now let us be in a position of saying, let's have number one. On number one, let's have a f of x is equal to 4x minus 5. Let me write that for x to be clear for us. All right. On number two, let's have now I want us to have basic things. Let me see. Okay. F of x is equal to 3x squared minus 1 maybe. Then on the third one, okay, on the third one, let us have on the third one, let us have f of x is equal to x squared. Okay. Actually, I should have started with that one. No, it's fine. Let me make this an interesting one. X minus 8. You'll never get it. You really get this one, but yeah, let's just do it. Okay. Then number 4, the last one. Let us have now what we call. Let me see. I want a unique one also. We're gonna look specifically on the specific graph that we have to deal with, right? Yes, but for now, I want us to look at these ones. Okay. Cool. Now let us be in a position of answering now. Number 1, f of x is equal to 4x minus 4. This is already the standard formation, right? the standard form, right? So now what I like to do, I like to say, f of x, it is the same as y. Okay? So just write it like this. Okay, it's fine if you don't and already swap. Okay, I always like to do this. Now this is the first step. Okay, what is the second step saying to us? The second step says to us, interchange or now swap x and y. Okay, the first one, the first one, the second one, you do what? You swap x and y. Why? How do you swap x and y? You now make x become y, then y become x. Hajwang, just swap them around. Just say now, I have where I see x, I substitute x. So where I see y, I substitute x. Where I see x, I substitute what? Y. Why? Because remember, we are reflecting across the line y, it is equal to x. Therefore, it means now y it is equal to x and x is equal to 1. So we are just swapping them around, okay? Then minus 5. Then remember the last step, which is to do what? The last step, it is to always find what? Y. Solve and what? Solve and make y subject of the formula. Solve and make y subject of the formula. How interesting. Make y subject of the formula. Okay, so how can I do that? I'll try to isolate for y by taking a negative 5 to the other side so that it becomes x plus 5. It is equal to 4 y. Now, how do I get y by itself? I get y by itself by doing what? By dividing by 4, by dividing by 4. Therefore, okay, I won't write divide by 4. Therefore, I have y, it is equal to what? X plus 5 divided by 4. Therefore, now, remember they wanted it in terms of what? In terms of very, very important to listen to examiner's instruction. Inverse, in the form of inverse something. I'm going to say, therefore, inverse function of x, it is equal to what? X plus 5 divided by 4. You are done. You can put it as, this can be said, it is what? X divided by 4 plus 5 divided by 4, which is the same as 1 over 4x plus 5 divided by 4. But for me, you don't need to do that. Okay? You don't need to do that. It's not necessarily important, okay? Yeah, it's not necessarily important for me, trust me. It's not. If you are good at math, you can try it. But if you know that you have a little bit of struggles, please do not try to attempt that. You might make silly mistakes. Remember, the examiner marks the final answer. Okay? Yes. On number 2, can you see now the momentum is raising now? Just say, okay, y is equal to 3x squared minus 1, then swap x and y minus 1, then have x plus 1, it is equal to 3y squared. People always make mistake when they arrive here, and I always get angry. I have what? X plus 1. I see I took this 1 to the other side. Then here I still have y squared. Then I need to do what? To divide by 3. I'm going to have x plus 1 divide. Actually, let me just say y squared, it is equal to what? X plus 1 divided by 3. Then I need to do what? I need to do what? To take a square root on both sides. But now remember, when I take a square root, I'm going to say y is equal to plus or minus. Plus or minus what? Plus or minus square root of whatever thing that I have inside, like that. Okay? Plus or minus. We're going to talk more about that plus or minus in further due. For now, let's just leave it. Then please just convert this to inverse. It is equal to plus or minus square root of x plus 1 divided by 3. You forget this, you are out. Very, 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 very important. Very, 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 very important. Okay? Yes. We're going to discuss exactly what that plus or minus mean to us. Then here, I don't think I'm going to have enough space, but it's fine. Let's just attempt. What do we do? Remember, this is y. We can just swap, okay? Swap already, which is y minus 8 squared plus 1. Okay? Then I take this one to the other side. It is x minus 1. It is equal to what? Y minus 8 Remember, it is all square. What you need to do, you need to remove the square. You need to remove the what? The square. Okay. But remember, when you do that, what will happen here? This will be plus or minus the square root of whatever that you have. Then here it will just be y minus 8, right? Y minus 8, or this one I want to do it in the next page where now I'll be explaining some few things. Then when I continue like that, I'm gonna say, okay, let me say here it is y, it is equal to that, therefore inverse of x, it is equal to plus or minus square root of x plus 1 divided by 3. Then here I continue and say, okay, I have plus or minus x plus 1, but I need to isolate what? 8. Okay, this is negative. When it goes to the other side, it's going to be positive. So it's going to be 8. So we're going to say y is equal to 8 plus or minus what? X minus 1. Can you see I took this 8 to the other side? Okay. You can say it is plus or minus x minus 1 plus 8, but it would be advisable to just put 8 as a what? As a coefficient like that. So therefore, I'm going to conclude and say, therefore, now inverse of x, it is equal to what? 8 plus or minus what? Square root of, sorry, x minus 1. How interesting is that? This is us just being in a position of understanding how we swap between x and y. Let us look now into logarithm first. Okay, let us look now into logarithm first. Actually, I won't do number 4. I won't do number 4. Okay, I won't do number 4. Let's start here and say, okay, let us have on number 1 the inverse. Now we are getting into serious stuff. Inverse, we're gonna deal with three functions here on the inverse: the straight line, the parabola, as well as exponential. Inverse of a straight line. Inverse of a straight line. All right, let me say inverse of a linear function. Linear function. Inverse of a linear function. So what exactly is going to happen here? We're going to say, okay, let us have an equation of a straight line, okay? So equation of a straight line, it is always y, it is equal to mx plus c, okay? Mx plus c. Then, actually, I don't want to show you the formula for the inverse, okay? Because now you will be in a position of wanting to cram it, whereas you don't need to, okay? So here it is y is equal to mx plus, let me actually use f of x, okay? F of x, it is equal to mx plus c or ax plus q, okay? Ax plus q, but I prefer us to use mx plus c that we are used to. So now let us now apply how to find the equation, how to draw. Okay, how to find the equation and how to draw. Okay, good. Number 1. Okay, let's have an instruction on our example. Find the equation of an inverse function. Okay, find the equation of an inverse function of inverse function. Find the equation of an inverse function and draw the two graphs. What do you mean? The original as well as the inverse on the same set of axes. All right. On the same set of axes. How? What is happening now? We started off smoothly. Now things are taking a U-turn. What is happening? No, there is nothing that is happening. Let us consider the first equation. Okay, let us consider the first equation, or let me say, yeah, yeah. If it is given that on number one, f of x, it is equal to negative 3x minus 2. We know these are easy stuff. So what do? We interchange x and y. We know this is x, then this, so we know this is y, this is x. So we'll just say, okay, x it is equal to negative 3y minus 2. Remember, I'm trying to solve for y at the end of the day again. Then I'll take this minus 2 to the other side so that it becomes x plus 2. It is equal to negative 3y. All right, then you'll see I'll divide by negative 3, negative on both sides. Therefore, I'll have y, it is equal to x plus 2 divided by 3. But remember, it is what? It is negative like that, right? Therefore, the inverse, okay? If they say leave your answer in the form of y is equal to mx plus c, then it's fine, okay? Then the inverse, it is equal to what? Negative x divided by 3. Can you see? But it will tower, so just leave it as x plus 2 divided by 3. Okay. Just leave it like that. Then what do? We have what? We have f here. Can you see that? We also have what? We also have the inverse. Now, what did the examiner ask for us? The examiner asked us to now to be in a position of saying, okay, draw those two graphs in the form of y is equal to, so draw those graphs in the same set of axes, right? So what will happen when I try to do that? What will happen when I try to do that? I'll say, okay, let me just divide my page into two. Okay, allow me to zoom out a little bit like that and be in a position of saying, okay, let me just divide my page into two. Okay, and say, okay, here I'll use the first one to say, I'll sketch on this one. Thank you very much. On this one, it will be my sketch. Okay, on that one, it will be my sketch. But remember, what do you need to sketch? You only need few things, such as what? Y-intercept as well as x-intercept, okay? Now we're going to say, okay, for f of x, okay? For f of x, that is the equation of negative 3x minus 2. We need to find what? The y-intercept as well as its x-intercept, right? Now, when we find y-intercept, remember we do what? We let x equal to 0. When we do that, it's going to be y, it is equal to what? Negative 3 into 0 minus 2, which is equal to how much? Negative 2. So it means now we have coordinates for y-intercept such that when I let x equal to 0, y becomes what? Y becomes negative 2. And say, okay, let us find now the x-intercept. Okay, the x-intercept now will be letting y equal to 0. How? Now saying, okay, this is me saying 0, it is equal to negative 3x minus 2. Then I'm trying to solve for what? For x. So it's going to be now, when I take this 2 to the other side, it's going to be negative 3x. And down now, x will be how much? 2 divided by negative 3, it is negative 2 divided by 3. And we're in a position of saying, okay, this in the form of coordinates now, this in the form of coordinates is now, if I have negative 2 divided by 3 as x, what is my y? My y, it is 0. Okay, remember this applies for all functions. Okay, then before I sketch, let us be in a position of saying, okay, we see now the coordinates of what? We see the coordinates of x and y for the original function. How about now the inverse function? How about now the inverse function? Okay, yes. There has been a position of saying for inverse function that goes like this. Where is that? It's here, right? It's gonna be negative into x plus 2 divided by 3. Then now, remember for x-intercept, we do what? We let, can you see now I'm taking you baby steps, but now as time goes on, I'll now be moving fast. For x-intercept, to let y equal to 0, therefore what will happen is going to be 0, it is equal to negative x plus 2 divided by 3. Okay, therefore, can you see now when I divide by negative is fine, then this 3, when I multiply by that, okay, it's going to be 3 multiplied by 0. It's going to be just 0. It is equal to, I don't know, just take, okay, first divide by negative here, okay? Divide by negative 3 on both sides, okay? Divide by negative 3 on both sides. When you divide by negative 3 on both sides, you get something like 0. It is equal to x plus 2. Therefore, x it is equal to negative 2. Okay? X it is equal to negative 2. It means now when x it is equal to negative 2, your y value it is 0. Now let us be in a position of saying, okay, let me get the x-intercept, the y-intercept. Okay, for y-intercept, I know I'll have to let what? Let x equal to 0 and say, okay, this is y, it is equal to what? Y it is equal to what? It is equal to, I want you to see something, okay? Okay. It's going to be just negative into 0 plus 2 divided by what? By 3, right? Therefore, just punch this on your calculator. You get a value of negative 2/3. Negative 2/3. What does this mean? It means now when my y, it is how much? My y, it is negative 2/3. How much was my x? My x was 0. But I want you to see something. We found negative 2/3 somewhere. We found negative 2 somewhere. When I try to do this, can you see now this? This is what? This is the very same coordinates as that one. Okay? But now, this is the y-intercept here. But here it is the what? The x-intercept. Oh, really? Here we also found, oh, sorry. Here I made a mistake. When x it is equal to 0 here, okay, we substitute x as 0, then we get y as negative 2/3. Okay, yes. We're going to say, okay, here we found 0 as 0 and, let me just highlight that, 0 and negative 2 divided by 3, but here I got negative 2 divided by 3 and 0. This was my what? My x-intercept, but this is my what? This is my y-intercept. Okay, what does this tell me? This tells me now that, remember, I'm doing what? I'm doing interchange x and y, right? So it means now, whatever coordinates that I have for y-intercept, when I go on my inverse, they are going to be what? They're going to be the x-intercept. How? The y-intercept of this one, the x-intercept of this one, when I go there, it's going to swap around and become the y-intercept. Can't it? Indeed. Now, let us be in a position of saying, okay, we are noting down that before we draw a graph, okay, it seems like we have something interesting. I don't know which color to use. Aibo. Oh, note. Okay. Since f of x, inverse of x is obtained from uh, from doing what? From what I want this word from reflecting F about the line y it is equal to x. Therefore, this tells us that the x coordinate, x intercept of f of x will be what? Will be what? Will be now y intercept of what? Of the inverse. Why? Because remember they are changing, they are changing. If it is x on the original function, it's gonna be y on the inverse function. Really? Yes. Just like that. Therefore, again, the y-intercept on the original function, it is what? It is what? It is x-intercept on the inverse function. Does this apply also on domain and range? Yes. Why shouldn't it apply? Yeah, it does apply. Okay, it does apply. Meaning now, remember whatever x, remember domain, it is all element of x, right? So it means now the domain of f, the domain of f, it is equal to what? Okay, domain, it is values of x. So it means it should be equal to y values of x. But what are y values? Y values, remember, it is the what? The range of the inverse. Oh, come on, come on. What are you saying? Indeed, I'm saying now, if you have the what? The domain of the inverse. The domain of your inverse, it is the same as now your range of your sorry, the domain of the function, it is the range of the inverse. Meaning if I have x is an element of real numbers on my on my what? On my original function, it means on my inverse is gonna be what? It's gonna be y is equal to an element of real numbers. Hi, mpo. Can you see now? It is no longer a domain, but it's the what? A range. Oh, can it? Yes. So does this mean now the range of f, it is equal to the domain of inverse? Yes. Why? Because now they are changing what? Positions. Okay. Actually, let me write it in full because people will say nakil domain of f of x, it is equal to the range, vice versa, to the range of the inverse function. Oh, now you are making a little bit sense, but we'll try to prove that when we reach our graph. When we reach our graph. This, I'm using this so as to show you that this is also reversible. The a reverse statement, it is also true. I almost said the reverse reaction. Okay, domain of, it is the domain of the inverse. You are lying. Okay, we have trusted you enough, but try to prove that for us. It's fine. Let us be in a position of saying, okay, we are sketching that graph. Okay, we are sketching that function. Those two functions on the same set of axes. All right, but we'll start first. Let's start first by sketching what? F. Sorry. Sketching what? F. Okay. Let us start first by sketching F. Let me just cut it here. I want to draw a big graph that is gonna be very, very good for us to be in a position of understanding, to interpret. Okay, X, Y. So now let's start with the graph of F. I'm gonna draw it in red. Okay, I'm gonna draw it in red. Then the graph of X, we only need 2 points. The x-intercept. Remember, this is the x-intercept. So this is the y-intercept. This is the x-intercept. Okay. So now y-intercept, it is 0 and -2. Where is that? 0 and -2. I can approximate it to be somewhere here, maybe. Okay. 0 and -2. Okay. Then I need another point again. Another point, it is what? Another point, it is -2, -2 and 3, negative 2/3, sorry, negative 2 divided by 3 and 0. Where is negative 2 divided by 3? Negative 2 divided by 3 is something like negative 0.667. Okay? So I can put it somewhere here and say now, this is another point that says to me negative, okay, negative 2/3 and 0. Okay, let me try to squeeze that. Negative 2/3 and 0. This is F. Then I do what? I take my ruler and say, okay, Mpo, be in a position of trying to join these points. It won't be necessarily straight accurately, but I want us to be in a position of understanding. Okay, let me erase these. I'll write them again. Okay, all right. So this is interesting, Mos. So this now, it becomes my what? My graph of F. You need to label, this is the graph of F. But now, okay, I need this point, it is negative. Okay, I'm lying 0 and negative 2. But remember, when I want to sketch the inverse, what is going to happen? What is going to happen is that, remember, I need to reflect that across the line y is equal to x. Which line is that? I'm talking about this line. Y is equal to x. Remember, I said it is this line here. That passes through the what? That passes through the origin. So just do dotted lines like that. So this is your it is equal to x part. Okay. So this is your what? Your graph of y. Not graph. Y is equal to x. Axis of symmetry. Okay. So I need to draw what? I need to draw an inverse. Stop looking around and doing what? Remember, I said whatever this point here you have on F, when you get them on the inverse, you just swap them around. So you just need to swap these 2 points, and get a coordinate of the what? Of the inverse. So it means it's going to be now 0 and negative 2/3. Where is 0 and negative 2/3? 0, it is here. Negative 2/3 is somewhere here. Okay. Let us put it somewhere there. And say this is 0 and negative 2/3. All right. Then we swap this one around. When you swap this one around, it's going to be what? Negative 2 and 0. It might be somewhere there. Okay, somewhere there, sitting nicely at negative 2 and 0. Are we in a position of drawing that? Yes, we are. How? We are. We'll just say, all right, let us just join those 2 points thereof. Yo, it is too tilted, right? Okay, good. Now, and say, okay, this is a function of, this might be the function of what? Of the inverse. What's important is that they should intersect, those two graphs. Those two graphs should have somewhere where they do what? Where they intersect. Please name this. This is the inverse. Okay? You can just say inverse of x, and this one, it is f of x. Can you see? Can you see? There is a point now where they meet. There is a point now where they touch. That point where they meet, it is a point that we say now it is where y it is exactly equal to x. What do we mean by that? We mean that in this point here, on the yellow shaded part, whatever coordinates that we have there, they are the same. What do you mean? It means now here, if we have the coordinates, when x it is equal to -1, it means y it is also -1 at those specific points. How can it? Yes. So it means here, if I have a coordinate here, -2, it means y it is also -2. If I have those coordinates as 4, this is also 4. 4 and 4. It tells us those coordinates are the same. Okay? There we have a what? Same coordinates. Same. From this point, we have what? Same coordinates. Coordinates. Okay? Just like that. So how can you see how easy it is? Now, let us prove that the what are these? the points that we got by swapping these ones around, are they correct now? The x-intercept, it is -2 and 0. Can you need -2 and 0? Yes. This is the x-intercept. -2 and 0. The y-intercept, is it where is the 0 and -2/3? 0 and -2/3. The y-intercept, yes. Can you see now? We will have reduced the stress by saying, okay, instead of writing x and y intercept again, or calculating x and y intercept again for the inverse, let's just swap. But I needed you to be in a position of understanding. Okay, yes. So now this statement, it is correct, proven, correct, proven. Okay, can you see this was the y intercept here? Okay, where is that? This was the x intercept here, but when it got there, it got as a what? As the y intercept. Okay. Now let's look at the domain and range, whether it is we are honest now. The domain of f of x, where is f of x? F of x, it is the blue line. Okay. When I check the domain, I use my ruler and say, where does it start? Where does it start? Can you see it starts where? It starts at negative infinity. Can you see that? Negative infinity. And ends where? And ends where? And end at negative infinity. So it means now, when we do that, we're going to say, okay, the domain of f, okay, where's that color? The domain of f, it is equal to what? It is equal to the domain of f, it is x is an element of real numbers, or you can say x from negative infinity to infinity. That's also fine, but I prefer to use x is an element of real numbers. Now let's look at the range of y. Range of y. What is the range of y? The range of y now, it is all element of y, okay, from bottom to top. Remember, on domain is from left to right, but now on range it is top to bottom. So now let's look at that. Can you see it starts where? Can you see here at this point where it starts? It starts at where? Negative infinity. Why do I say it is negative infinity? I see by arrows. I say, okay, the domain, it is what? Y is an element. Oh, it starts from negative infinity. It goes to where? It goes to where? Can you see now this point here? It is what? Arrow. It tells us it is what? It is infinity. So it tells me, all right. So it means also the range of Y. So the range of f, not range of y. Range of f, it is y's element of real numbers, right? But what did we say? We said the domain of the inverse, range of the inverse. We said the domain of the inverse will be the same as the range. Okay? What was x before is going to be y. What was y before is going to be what? Going to be x. Let us be in a position of proving that. Now let's look at the graph here. Let's look at the range because we are already at the range. The range of the red graph, which is our inverse. The range starts from where? Can you see now? It starts from negative infinity. Up to where? Up to positive, positive infinity there. Huh? Can it? Yes. So what does this tell us about the range of that graph? So the range of that graph, sorry, it is also what? So the range of that graph, it is what? Why? Because we are talking about the range. Y is an element of real numbers. What is the domain of that? Can you see now the domain is equal to the range? Can you see the same element of real numbers? Okay. So now I'm saying, what is the domain of f? The domain of f, can you see it has arrows here and it ends at the arrow there. So it also tells me the domain, it is x is an element of real numbers. Can you see now it is the same as the what? As the range there. We are looking at these. We are interested in these. These. Can you see they are the same? Okay. Similarly for those two, these are the same. What's gonna change is that this one is the domain, this one is the range. Okay, just like that. We are done for inverse of a linear function. That was very straightforward. Now I want us to look at this one. Before I'm gonna end with the inverse of a parabola. Okay, yes. So I'll just say, okay, let us look at the inverse of a inverse of a logarithm graph. Okay, inverse of exponential. So inverse of an exponential graph. Exponential graph. Okay, yes. Let us be in a position of understanding that. So our logarithm graph is going to be in an equation f of x. It is equal to a to the power of x. Okay, so we just say a to the power of x, just like that. Okay, we want to do many things. Okay, yes. Now we need now to look at what we refer to as rules. Rules of what? Of logarithm. Okay, logarithm laws. Okay. um Rules of logarithm. Okay, why do we need to come and say we need rules of logarithm? Assume that you have this. Assume that you have y, it is equal to actually f of x, it is equal to a to the power of x. Okay, now try to solve for the inverse. Try to solve for the inverse. What are you gonna do? What you're gonna do first is you're gonna say, okay, this is the same as y, it is equal to a to the power of x, right? Remember, what are the first step of finding the equation? You interchange x and y, okay? X, it becomes a to the power of y. What is the last step? The last step it is to what? Find y as a subject of a formula. Can I do that? Can I do this y, y, and cancel this? This is going to be a, it is equal to root of y, x. Am I still finding y? No. So this is wrong. What you have here, it is wrong. What exactly am I supposed to do? What I'm supposed to do is say now, okay, instead of squaring now, because this is not the same as y is equal to y to the power of a, where you can square by a and it cancels off like that. No, this is a to the power of y. What do you need? You need to drop this y down here. But to do that, when you drop that y there, remember to introduce what we call log. Okay? What do I mean by that? You're gonna say, okay, I'm gonna change. Okay, I need you to hear me very well. I need you to hear me very well. You're gonna need to say, okay, take this. I wanted this y to be in the position of x. Okay, therefore it means this x should be in the position of what? Of y. Then what? Can I just say y is equal to a to the power of x? No. Why? Because I'm going back to the original function. But instead, I'm gonna say, if I want to do that, I'm gonna need to introduce something special. I'm gonna say, okay, I want to drop y like that. Okay, I'm dropping y like that, and I want y to be equal to something. But why, when you drop it like that, you need to introduce what we refer to as log. Okay, log what? Then this one, it is the base. It remains the base. You're gonna write it down here, and then now that's when you can say, okay, I can swap your position now. You can go there. Then it becomes what? It becomes x like that. Can you see? We have achieved a to the power of x, okay, by dropping y and x. But now we introduce a little extra thing, which is now what? Log, log, log that, right? Yes. Can you see that? Oh, so it means now the inverse for this one is going to be f of x is equal to log of x base a. Okay. So now how about I find another interesting equation? How about now I find an interesting equation? I'd say, okay, let us be in a position of saying we have now f of x, it is equal to, what can I say? 4 to the power of x. Okay? How can I solve this? I'll just say, okay, this is y is equal to 4 to the power of x. I haven't done anything. What I've done, I'll do now is rearrange. X is equal to 4 to the power of y. But remember, I do not want what x is equal to something. I need what? this y to be the subject of a formula. Remember what will I do? What I'll do, I'll just drop this and say, okay, it is y. But when I drop it like that, I need to introduce something special, which is log. Then whatever that is here, the base will remain the base. Not here, but down there. Okay? Down there. Then what will happen? This one can now say, okay, I might go rise there. When it rises like that, it becomes what? X like that. X like that. Yes. But I want you to see something. When you move from exponential, when you move from exponential to log, okay, it's gonna be just for exponential, it's gonna be f of x. Then when you move to log, it's gonna be log of f of x. Hi. What is this guy saying now? Check. What is f of x? I go. What is f of x? F of x is equal to a to the power of x. I said when you want the inverse, this is the inverse of exponentiality is log, right? This is the inverse. Okay, the inverse of exponentiality is logarithm. Okay, now I'm saying if you have f of x is equal to something, that something is going to be log for inverse is going to be log of whatever that something. Check what is f of x equal to. F of x is equal to a to the power of x, right? I say when you go to the inverse, it's going to be what? Log of f of x. What is f of x? F of x, it is a to the power of x. Hi. You are cheating. No, it is acceptable. It is the same. Check here. What is f of x? Can you see log of that one? Here, what is f of x? F of x, it is equal to 4 to the power of x. Then what is our inverse? Our inverse now, let me just conclude. Therefore, our inverse, it is equal to log what? Let me try to zoom that for us. Log what? Log 4 to the power of x. Hi. Can you see? F of x was 4 to the power of x, but here it is log f of x. What is f of x? F of x is 4 to the power of x. Hi. Can you see now? This is what I refer to now. Okay? This is what I refer to. Now let us be in a position of saying, okay, let us draw the graph and also what we did here. Okay? Let us take this example again. I am very lazy to rewrite. Okay. Now I copy that. Thank you. Then I just come and paste it where? Here. As part of my example again. Okay. Yes. Now, cool. Right? Cool. Let us say I have now an equation that goes like, here I had what? Maybe so that I do not mix something. I had, okay, f of x. Let us have f of x. It is equal to, it is equal to 1 divided by 5 to the power of x. Okay. And another thing that I need you to remember okay, I'll just go to that. F of x is equal to 1 to the power of x. Now, find the inverse. How do you find the inverse? You don't need to interchange x and y. You can do that and say this is x, it is equal to 1 over 5 to the power of y. But you know, at the end of the day, y is going to be what? Log of whatever f of x is. What is f of x? 1 over 5, okay, to the power of what? To the power of x. How interesting. You can also put this inside your parentheses. It's fine. Okay? Or your brackets. It's fine. This is it. Okay. Therefore, it means my inverse it is what? My inverse it is log what? 1 divided by 5 to the power of what? To the power of x. Very good. Very interesting thereof. Now, remember they want us to do what? To sketch. What I do, remember what I do? What I do, I will find x and y intercept of this one and interchange them. You are clever now. Indeed. So I'm going to say, okay, for x-intercept, I'm going to let y equal to 0. Then it's going to be what? It's going to be this one, right? I'm looking at f of x for f of x, right? Let me just indicate that for f of x. Cool. Now, what do we do for x-intercept? You let y equal to 0. So it's going to be now 0, it is equal to what? 1 divided by 5 to the power of x. Okay? Y to the power of x, right? Now, can you solve this? Can you, Aman? Oh, yeah, it is. Can you solve this? Y it is equal to 1 over 5 to the power of x. Okay? Can you do that? Even if you try to laws of uh, the laws of exponents, the logarithm or what, try to solve for x, you're gonna drop this one again. Okay? So when you drop that one, it's gonna be x, it is equal to what? Then if you want this 0 to become there, it's gonna be like log of what? Log of what? Log of 1 divided by 5. Then I raise that to the power of 0. Then take your calculator. Take your calculator and see what is the value of x. It should be undefined. You're going to use the log that has something like log small thingy and big thingy like that. Okay, yes. So it's going to be log 1 over 5, okay, divide to the power of 0. This gives me undefined. Okay, so this gives me what? No solution. No solution. That's fine. That's fine. So it means I do not have x-intercept. So I have what? No x-intercept here. No x-intercept. Okay. Does that worry me? No. Let me say, okay, let me find my what? My y-intercept. My y-intercept, I do what? I let x equal to 0. And you could have sketched this graph very easily just by saying, okay, I remember I have done what? I have done exponential graph, and I know when A or B, it is between 0 and 1. Huh? 0 and 1. Okay, yeah, -1 and 0. Okay, when it is between -1 and 0 like that, if I still remember very well, let me just confirm that. Or if it is between 0 and 1, basically, 0 and 1. I like to say the value of a. It is between 0 and 1. Your function should be what? It is a decreasing function. If you can't remember that, watch a playlist where now I recorded the the exponential function, okay? Yes. Now it's gonna be a decreasing function. So from left to right, it's gonna just decrease like that. Okay. And always this point here, when you have a standard like that, it is always 0 and 0 and 1. So can you see there is no what? There is no x-intercept. Why? Because now you have a what? A horizontal asymptote at y is equal to 0. Okay. So it means now at x is equal to 0, it is an asymptote, okay? Yes. So now let's try to find y-intercept. It's going to be 1 either way, I know, but it's fine. For y-intercept, I let x equal to 0, so it's going to be y is equal to 1 divided by 5 to the power of x is equal to, so to the power of 0, which is equal to 1. So this tells me, well, okay, if x is equal to 0, y it is equal to 1. Okay, then am I in a position of sketching the two graphs? No, why? Why no? Because now you haven't found or find the x and y intercept for the inverse. Do I need to do that? No. Why? Because now I can interchange whatever the values I have. Oh, that's so smart of you. I know, right? Then let us be in a position of saying, okay, let me sketch that. Yo, let me sketch that. Okay, let me sketch that quickly thereof. x and y. Remember, f of x, it is 1 divided by 5 to the power of x. Okay? So it is a decreasing function. Why? Because I know the value of a is between 0 and 1. You need to know this. You do inverse function after doing functions. So if it is a decreasing function like that, can you see it has no x-intercept? So it means it won't touch this line anyway. It won't touch that line. But it has a what? It has a y-intercept at 0 and 1. 0 and 1. Where is that? I can put that here and say this is what? 0 and 1. So what will happen? What will happen is I'll just say, okay, this will be a decreasing function like so. It won't touch this one. It will approach that, but won't touch. This is my what? My f of x. Okay, cool. We are saying that we are shining. But how can I draw the inverse function? How can I draw the inverse function? It's fine. It's easy. Just say, okay, this point it is 0 and 1. Just interchange it, okay? It's going to be what? 1 and 0. 1 and 0 somewhere here. 1 and 0. But the question is, how is my graph going to look now? Because am I going to do what? Because now it is touching the what? The x-intercept here. I'm going to explain why this one is touching the x-intercept. But what will happen? How can I draw the graph? You can just find any point here, like there, something like maybe when x it is equal to -1, maybe -1. Yeah, just check when, just have any point. Okay, let me do this. Just have any point where we have x it is equal to -1 and check how much it gives you on the original function. Okay, just put -1 on the original function, which is f of x, here on this graph. Okay, it's gonna be 5. Okay, but let me just confirm that it's gonna be 5 because now I'm taking its inverse. You get how much? You get 5. Okay, so here we have a point of 1 and 5, -1 and 5. So you need to interchange that point to make it what? 5 and -1. Where is 5 and -1? 5 and -1. 5, it will be x. I interchange this to 5 and -1. 5 is x. 5 is x. Somewhere there, maybe -1, it is somewhere here. Okay, can you see that? I have a point that I interchanged to what? To 5 and -1. Okay, I see something like this here. Okay, let me remove this. This was 1 and 0, right? I see something like, okay, I have a point there, and I also have a point here. Can I join those points? Yes. But where are they going? Can you see they are making a shape like that? So I need the other part. And remember, you need to reflect it across this line here. Y it is equal to x. Okay. Then can you see I had a point here? I had a point in the middle. Let me have a point here so that I'll now see exactly what I have. Let's put x as I don't know. Okay, let us put x as half. Okay, if this is 1, half might be somewhere here. Okay, x as half, positive half, and see what we get as y. So it's gonna be 1 divided by 5 to the power of half. Half it is 0.5. You get something like 0.4444 as a value of y. Okay, so you get something like 0.447, which is 45. Okay, then now you're gonna interchange this coordinate into 0.45 and half. So 0.45 it is x. If this is 1, 0.5545 might be somewhere here. Then half might be somewhere. Half it is the value of what? Oh, I'm interchanging this into what? Into 0.45 and half. So where's half? Half it is somewhere here. My y value it is half. Okay, so this point here, it is unreasonable. It should be somewhere here. Half is here. If this is Hey, this is 1 again. Half is going to be somewhere here, maybe. There. I'm sorry about that. I need to shift this point here to say, okay, this is my 0.5 and what? 0.445. Then now, where can I plot 0.45 and 0.5? 0.45, it is the x. It is somewhere here, less than 0.5. Can you see that? Then, where is 0.5? 0.5 should be somewhere in the middle. Somewhere in the middle. Somewhere something like so. Don't know. Okay. Then it will do something like this in eventual. If I do not stress myself enough. Okay. We don't need this point. It's fine. Without it, it's fine. Okay. Such a weird graph. Cool. But now I need you to realize something. I need you to realize something. This is a decreasing function, right? F of x is a decreasing function. It's a decreasing function. Okay. Similarly, can you see now also the inverse is a decreasing function? Okay, it is a decreasing function, but it touches the x. But can you see f does not touch the x? Okay, does not touch the x-intercept. But can you see that the inverse does not touch the y-intercept? Hey, come back. Can you see now my inverse does not touch the y-intercept? What does this tell? Remember, whatever that x does, y will do the inverse. Okay, whatever f does, the inverse will do it, but in y direction. What do I mean? F of x does not touch x. So it means the inverse should not touch what? Y. Can you see? Okay, let us talk in terms of domain and range. In terms of domain and range, remember we said, or I said, the domain of f will be equal to what? The range of the inverse. Let's try to prove that. Let's find the domain of f and the range of y. So the range, I like to say the range of y. Let's find the domain of f and the range of f and see exactly. What is the domain? The domain is all x is an element of real numbers, okay? I'm sorry, all x values, okay? So now let's come here. F of x is here. Can you see where it starts? Can you see where it starts? It starts at negative infinity. Can you see here? I see by this thing here, the arrow. The arrow tells me. So it starts from negative infinity. It goes to where? Can you see I'm going until it goes where? Can you see here? There. It goes to what? It goes to positive infinity. What does this tell me? It tells me now the domain of f. The domain of f, it is x is an element of real numbers. It is found everywhere on the real element of real numbers. Remember, you can say x is an element of negative infinity to infinity. That's also fine, okay? Yes. Now let's find the range of f. What is the range of f? The range of f, sorry, is all element of y. All element of what? Of y. Where does it start? It starts here. Can you see? I catch it here, where what? X is equal to 0. But now, can you see where x is equal to 0? It is here. Does my graph touch where x is equal to 0? Sorry, this is the range. So I'm looking at y values. So y is equal to 0 here at x intercept, okay? Can you see? Y, it is always 0 there. So at y is equal to 0, does my graph touch? No. So it means my graph, I find it above. Starting from something above 0, I find my graph. Can you see? Here's my graph. But it does not touch what? Y is equal to 0 at x, okay? So what does this tell me? So it tells me I find it from 0, above from 0 to where? Can you see now? It goes up until it goes to what? To infinity. You do not say it starts from negative infinity. No. Where it starts, can you see? This is not negative infinity. It will have started from negative infinity if it was floating here. Okay. So here it starts from what? From 0 moving upwards. But now the question is, since well you said it does not touch 0, how can I write this? I'm gonna write this by say it is y is an element of what? It starts from 0, but can you see I'm not including 0? I am not including 0. Why am I using square brackets? It tells me it does not touch. It does not include y is equal to 0. It does not touch y is equal to 0. Oh, really? Yes. To what? To infinity. Some might write it like y should be greater than 0. When y is greater than 0, from 0 0.1, 0 0.2, it goes up to infinity. It is fine like that. Okay. So yes. So here let's just say for purpose of just niceness, negative infinity to positive infinity. Now let us talk about the domain. Remember I said the range of f. So the domain of f is going to be what? The range of the inverse. The range of f is going to be what? The domain of the inverse. Let us come with me and now prove. Come with me and now prove. I'm expecting this to be what? This is the domain. It's going to be the range of the inverse. I'm expecting this to be y is an element of negative infinity to infinity. And then x domain, again, can you see? From where? 0 to infinity. Let us prove. Let us prove if our statement is correct now. Can we see? Let's start here and say, okay, since well it is horizontal like this, let us look at the range of the inverse, the red graph. The what? The range of the red graph, can you see where does it start? It does not start somewhere. It is not stopped by something. Okay. This one was stopped by this one, where y is equal to 0. But this one, it is not stopped by something. Can you see? So it means it floats until it goes everywhere. It means it goes until negative infinity, right? So, okay, if that one is negative infinity, it means now it starts from negative infinity, like that negative infinity, then it ends where? It goes up until it goes where? Can you see? It goes up. I'm talking about the y, not the x, this line here. I don't care about that line. I'm talking about the y here. It goes where? To positive infinity. This graph will look more or less something like extended like that without touching the y. Okay? So do you agree with me now that the range, let me just do this. The range of my inverse, it starts from negative infinity until it goes to positive infinity. This is correct. Okay. Then is this the same for the range? Okay, can you see the range of f is going to be the domain of inverse from 0 to positive infinity? Let us try to prove that. Remember I said range starts from left to right. So from left, can you see? From negative infinity, I come. I do not see red graph. I do not see red graph. But when I reach x is equal to 0 here at y, I see, okay, after just jumping x is equal to 0, or just jumping the y axis, I see what? I see my graph there of, it is a what? It is a great graph. It is my inverse. So it means when I just say anything greater than 0, but not including 0, I start to see my graph here. Can you see my rule? I start seeing my graph. I start seeing my graph. I start seeing my graph. It goes. But where does it go? It goes to what? To positive infinity. Can you see? It goes infinitely from this point 0 up to x is equal to 1, x is equal to 5, x is equal to million, x is equal to infinite. Can you see now it moves from x is equal to 0, but 0 is not included. Why? Because it does not touch that line there, that line. Okay, so it does not touch that line. To what? Can you see it goes to what? To infinite. So it should be something like this, and it is the domain. So it's going to be x is an element of 0, not including 0 to infinite. Is it true? Yes. Can you see? It starts from 0 but does not touch 0. If it touched 0, maybe something like so. If it touched 0, you're going to include it. But now it is not touching, we're going to say like that. Okay. So it acts as an asymptote. If it does not touch, you open like that. And remember, infinity it is always excluded because you do not know the exact number. Okay. Yes. So that is it. That is it. Summary on how to draw the graph. Okay. Summary on exponential and the log graph. Remember now, remember now, exponential, the inverse of exponential, it is log. Okay, the inverse of exponential, it is log. The inverse of log, it is what? Exponential. Before I go anywhere, before I forget, let us come here and say, is f of x a function? Is f of x a function? Yes, why? Because now when I do a vertical line test anywhere on f of x, the blue one, can you see here? It touches the graph how many times? Once, and there. Can you see that? Then okay, it means now f, it is a function. Then here, why is it a function? The vertical line test touches once. Let's look at the inverse. The inverse, is it a function? Yes. Why? Because now the vertical line test touches the graph once. Okay. So this one is the many one to one function. Why? Because check. For every one value of x that I input here, I get one value of y. Oh, okay, that's interesting. Similarly, on the f1, whatever x value I put here, I get one unique y value like that on the graph. Do not say here I get this. This is not a graph. There's no graph here. Okay. Yes. Cool. So straight lines are functions. Okay. Hence we study them under functions. Okay. This one also is the inverse. So is f of x a function? When I do a vertical line test, yes, it touches the function once at that point. Okay. Then is the inverse a function? Yes, it touches my inverse once at this point. Okay, so it is also a one-to-one function. Cool. Summary of exponential and log graph. Now, log graph, how do I draw log graph? How do I draw log graph? I say, so exponential graph. I'm going to say when a, remember I have y, it is equal to a to the power of x. Okay, so when a, I have condition. When a, it is between 0 and 1, we say that it is a decreasing function. Okay, but now when a is greater than 1, we say it is an what? It is an increasing function. What do you mean, manje? Hi. What I mean is this. Okay, I don't need a rule, it's fine. What I mean is this. I'm gonna have a graph like this, like that. Okay, y, x. So I'm gonna have a graph that's something like it is a decreasing function. Okay, it is a decreasing function, like that. Remember, it does not touch what my x axis. So this is my graph of f. If I per se it. Remember, this coordinate is always 0 and 1. Okay, then I come here and say, okay, what does when a is greater than 0? When a is greater than 0, meaning something like 5 to the power of x. Okay, then here maybe something like half to the power of x or whatever fraction to the power of x. Okay, then here I might say, okay, let me be in a position of drawing my axis. Okay, my axis like that. When I draw my axis like that, it's gonna be y and now x. So I'm saying this one is increasing. So this one was decreasing from where? From left to right, it is decreasing. So meaning this one from left to right, it should be increasing. Oh, meaning from left to right, it should be increasing like that. What is this point? Remember this point, it is always what? 0 and 1. So this is also f, but when a is greater than 1. So now the question is, how is the inverse going to look? How is the inverse going to look? Can you see? How is the inverse going to look? I don't need to know the equation of the inverse. I need to know whether my original function, this one, is it decreasing or increasing? It is decreasing. Okay. But remember, my graph does not touch x. Okay. My original graph, which is f, does not touch x. So it means my inverse won't touch what? Won't touch y. So what will happen? Will I draw it in here? No. You will draw it on the positive. Can you see I'm drawing this on the positive y? Okay, so it means this one will also draw on the positive x. Remember, whatever you do on the f, when it comes there, it becomes what? The x, okay? So here I'm gonna say, okay, it is a decreasing function, okay? So it should decrease from left to right, Leon. From left to right, it should decrease, but it should not touch this line. What do you mean? Should I do it like this? No, can you see it touches the y-intercept? And it should not. Why? Because this one does not touch the x. It means the inverse should not touch the y. So it should be something like it should decrease from left to right, but in that manner. Oh, like this. Yes, this is my inverse. And this coordinate here, it is always 1 and 0. Why? Because it is interchanging there. They are interchanging. This was 0 and 1. Then when I interchange that, it's going to be 1 and 0. Okay, that's so cool. Then what about this one? This one here, it does not touch the x-intercept, okay? So it means the inverse will not touch the what? The y-intercept, okay? So remember, you also have a line that goes like that. That is y is equal to x, okay? Then, okay, here I see, okay, it is an increasing function from left to right. So does this make this one an increasing function? Yes, from left to right. Here, no. Why? Because now it does not touch this y here. So if it does not touch that y there, this one there, what will happen? What will happen, I will start from here. Let me just do this. I will start here from left to right. From left to right, I'm going to increase. How? I'm going to just, sorry, let me repeat that. I'm going to just increase. I don't know why my pen is. I'm going to increase like that. Oh, so you are also increasing. Yes. It might not be that good as I want it, but it is also an increasing function. Democrat. Ish. The last time, it's fine. Yeah, it is like this one. It does not touch. This one does not touch. So, okay, what does this mean? Let me take this a little bit. Okay, then what is this point? Remember, this point will be just the inverse of this 1 and 0. Okay, so where does my y is equal to something stands? It stands somewhere here. But this one does not touch like others. Yes, this one does not. Okay, this is that. This is that. Then this is my original function f. Okay, let me just say it is f of x, f of x. Then this is my what? My inverse here. So this is also my inverse like that. Oh, okay. That's cool. That's cool. One might say, okay, so how do I move? Okay, here we explained that when you move from 1 divided by, okay, here, when I move from this one to log, I do that. So how do I move from log to original? It's fine. It's easy. If you're given, let's say, let's call it this g of x. It is equal to log b to the power of c. Remember, remember what you do. Remember the original function was this one, okay? Was this one. So you're gonna say, okay, this is since when my original now it is my log. Remember, inverse of exponential, it is what? It is log. But inverse of log, it is what? Exponential. So I'm gonna say, okay, it means now my original it is log. I'm starting here. It means I need to go to exponential. So it means now I need to say therefore g of g inverse of g is going to be what? Remember, my original function, it is always something that's here. Okay, so but now it's going to be the inverse of g. So it's going to be just b to the power of c. Can you see that? Can you see that? You can try by saying, okay, this make this one x, or let me just say this is y. So let me x. You can say, okay, let me change this. This is x. Then this is log y. But now remember, you want what? Y down there. Okay, so when you want y down there, you're going to say it's going to be y. Remember, at first, you introduced log, right? But now, if you already have log, if you want to reverse this part, it means you have to remove the log. When I remove the log, it will be just b remaining. Therefore, I just take this one and swap the position. It will become b to the power of x. Can you see now? Hence, I said this will become whatever that is thereof. Okay, so you don't need to stress yourself a lot. So it means now the inverse of g in this case is going to be what? Whatever this part it is, b to the power of y. So it's going to be b to the power of 4. Oh, so b to the power of that one, the original that you have, x. Okay, b to the power of x like that. Just is like that. Cool. Now I need to go to very, 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 very interesting part. Very, very, very interesting part now, where I talk about now the inverse of a parabola. Okay, I need to talk about the inverse of a parabola. Okay, yes. Mm, Before we do that, can we have at least a few equations under log and what and what? So let us solve for m. X, m, n, okay, x, y, or z in the following. You can also take notes, it's fine. Pause the video, write out notes and all of that. Okay, it is fine. Now let us have I want a unique number. Let me see. 10 to the power 10, 24. Okay. Okay. Let us have 20 on number A. 2048, it is equal to 2 to the power 2 into 1 over 2. Let me make it 1 over 2. Okay. Can make it 1 over 4 to the power of m minus 1. Okay. We also use this on a geometric series, okay, on number patterns. So 2048. So I'm trying to solve for m. What will I do? I'll divide first by 2. I get 10, 24. It is equal to what? 1 divided by 4 to the power of m minus 1. Remember, you can rewrite this. 1 divided by a, it is the same as a to the power of negative 1. Okay, so you can rewrite that as what? As 10, 24, it is equal to 4 to the power of negative 1, m minus 1, like that, right? Now, the question is, okay, I now have, okay, let's just carry on simplifying. I want you to understand this. It's going to be negative 1 multiplied by m, it is negative m. Negative 1 multiplied by negative 1, it is positive 1. Okay? I want you to understand something. The base here, it is 4. Remember, when you apply laws of exponents, we need the same base before we equate the exponents, okay? Yes. So what you might do, this is step 1. From here, this is, okay, from here, this is step 1. I'm going to show step 2 on this side, okay? You can say, okay, I need this to have the same base. Let me say 1024 on my calculator, equal sign, shift, then fact. Remember, fact, it is something that's like this. Okay, on your calculator, at the top, it is written fact, and it has B, letter B. Then, when you do that, you get what? 2 to the power of 10. Okay, so this is 2. So it means I need to make this 2. How can I do that? Remember, 4, it is 2 to the power of 2. I leave negative m plus 1 outside, then it's going to be 10 to the power of 2. It is equal to what? 2 to the power of, then I multiply out 2 multiplied by negative m is negative 2m. 2 multiplied by positive 1, it's positive 2. Now I have the same base. I can do what? I can equate the exponents. 10, it is equal to negative 2m plus 2. When I take this to the other side, it becomes what? 10 minus 2, it is 8. It is equal to negative 2m. Then divide by negative m is equal to what? Negative 4. Okay. But isn't there any easier way? There is. Now that you are introduced to logs, there is an easier way. By saying what? Okay, when I come to this step, I can just say divide by 2, it is 10, 24. It is equal to 1 divided by 4, m to the power of 1. Minus 1 to the h 1 divided by 4 to the power of m minus 1. What do I want? I want this as my subject of a formula. Remember, I want whatever that I'm solving for. But remember, it is not going alone. It is going with m minus 1. So it's fine. What do I need to do? I need this one to be down there. So I need this one to be down there. When I need that one to be down there, it's going to be m minus 1. It is equal to. But remember, I do not just drop that one. Immediately when I drop that one, I need to introduce what? Log. Oh, okay. Log of what? Whatever that we have here. What is that? 1 divided by 4 to the power of what? then you know that this one will say, okay, it means now go there. Hey, you fill up the space. So they took my space. Then, okay, 10, 10, 24. Then you're going to say m minus 1, it is equal to, you take your calculate, log, what is the bottom part? Okay, remember it's gonna, your calculator is gonna give you something like small box and a bracket, a box like that. You need this log here so that you can punch this. So on the small block, I'm gonna say divide 1 divided by 4. Okay, I'm gonna punch this 1 divided by 4. You don't need to include it inside the bracket, okay? Then the exponent there is 10 and 24. How much do I get? I get something like negative 5. Okay, so therefore I can solve for what? For m. M is equal to negative 5 plus 1, it is negative 4. Can you see now we have the same value here? We have what? The same value, but in this case here we used what? Logarithm. Okay, logarithm rules. Use the rules of logarithm thereof. Okay, so I'd prefer you to use this one, because now you are already introduced to this one from term 1, I think. From term 1, I think you are introduced to this one when you're doing inverse function. Remember, inverse functions are done in term 1. Okay, yes. So, okay, we can see things are flowing nice, but now we need something. Remember, we also proved that these are functions. Okay, this is a function, this is a function. Okay, then now the last one, the inverse of a what? The inverse of a parabola. Oh, this one is interesting. They like to assess this one a lot. Inverse, let me write it here. Inverse of a parabola. Okay, yes. So now we know the standard for a parabola is going to be now f of x. We're going to use this one, ax squared. Okay, they can add plus q, it's fine, even if they do not add it, right? So now let us have a function where our function, it is given the name of okay, I think I need to make an example. Paste. Thank you very much. So we're going to apply the very same thing. Find the equation of an inverse when we are given the original function, then do what? Draw the two graphs, right? On the same set of axes. Okay. Now let us have just a basic equation. F of x, it is equal to power sign x squared. X squared. Okay. Just have f of x equal to x squared. So how can I find the inverse? Remember, how do you find the inverse? You interchange x and y. I'll just write this as y is equal to x squared. I haven't changed anything. This is still the same thing. I'm just rewriting f of x as y, right? Then, okay, then what you're going to do? What I'm going to do, I'm going to say, okay, I'm now interchanging x and y or swapping them. It's going to be y squared. Unlike 2 to the power of y, where you introduce log, this is y squared. So you can take the square root, okay? I do not want you to confuse that. You can take the square root on this side and say, okay, take the square root of this one, also take the square root of that one. But remember, when you take the square root of something, this is going to be y, it is equal to that something is going to be plus or minus what? Square root of x. Okay? So, okay, I have this now. Then what? Then what? Then this is just your inverse function. Okay. Why do we always see plus or minus on parabola? Because even here we had a standard parabola. Let me try to reach out to that here when I was showing you the steps. We had a parabola. This is a parabola, right? Can you see? Can you see we also had what? Plus or minus like that. This is also a parabola, plus or minus. So what do they mean? Those plus or minus. I'm with you. I'm with you. I'm with you. I'm going to tell you where exactly we need to use those ones. So now, we need now to be in a position of saying, okay, okay, okay. Can you see now here, the domain of this one? Okay, what is the domain of this one? Remember, x here, okay? X should always now be what? X. Remember something inside the square root. What is it that is not supposed to be there? Remember, this should not be negative number or what again. So this should always be whatever inside the square root. Even if you have x divided by a, whatever inside the square root, x divided by a, should always be greater or equal to 0. Why? Why? Because now, remember, we are trying to avoid what? Having a negative number. So it can either be greater than, it needs to be greater than 0 or equal to 0. Why? Because we also have a square root of what? Of 0. Square root of 0, it is 0. Okay? Square root of 1, it is 1. Square root of 4, it is 2. But now, can you see when we have square root of -1, this is an imaginary number, okay? You haven't done it in high school yet, okay? So hence, for now, we just say we do not have a square root of a negative number. So hence, we need to include and say, okay, we need our x to be greater or equal to 0. What if I had something like this? Plus or minus square root of negative x. Even if you divide by a or what? Negative x. What is going to happen? You need your x to be how? If x is, remember, x greater than 0 means this value need to be positive here, okay? Now, already x, it has a negative sign. So what can I do to this one to make it negative? What can I do? Just say, fella, negative x needs to be greater or equal to 0. Whatever that is inside the square root should be greater or equal to 0. But remember, I'm trying to solve for what? For x. Therefore, when I solve for x, it's going to be x. When I divide by negative, remember, when you divide by -1, the sign change. The sign will change. What do I mean? From now, negative x is greater or equal to 0 is going to be x is less or equal to 0. So this will be now my new restriction. This is what we refer to as a restriction. So, okay, why do x need to be equal to 0? Because if x, this means now x should be negative, okay? This means now x should be negative. Why do I need x to be negative? Check, plus or minus negative. If x is positive, it's going to be just +1. Just say square root of -1 or share how you calculate. It gives you math error, right? But now I'm saying restrict such that x is less than 0. X is less than 0, it means it's negative. So I can say, okay, how about I put -2? So when you put -2, it's going to be square root of negative into -2. You see, it's going to give you a number, which is square root of 2. So even if I put -1, it's going to give you what? 1. Oh, so this is how it works. Never mind this one for now. I'm going to explain this. I'm going to explain that. Okay, I'm going to explain that. So this is what I basically mean. Okay. Mhm. So let us be in a position of drawing a graph. You know how to draw a graph of f of x equal to x squared, Mos. It's basic stuff, right? It's basic stuff, right? I no longer need to do the x and y intercept secretary in like mode. I'm gonna just need this. Why? Because, so just imagine asking a teacher why, and it's the teacher says because. Now remember, what is the graph of x squared? The graph of x squared is gonna be just like this. Okay? Yo, Mdimo Christ. Okay, more or less something like that. I want precision. Okay, it's fine. Like that. This is the graph of x, right? Is this a function or not? Before we go anywhere, is this a function or not? When I do my horizontal, so my vertical line test, it touches my graph how many times? Once. So I'm gonna say f is a function. Okay? F of x is a function. Okay? Is a function. Let me just write it here. A function. Okay. This one, so how will I draw the inverse for this one in good subtly? Mukha hanang mo ka ting. Much better. Not better, but yeah. So how am I going to draw the inverse? The inverse, okay, the coordinates here for the original, it is what? 0 and 0. Can you see? So it means the coordinates for the inverse is going to be 0 and 0 because when I interchange 0 and 0, it's going to be that. Oh, okay, that's so clever. Remember, it is an equation of, I want you to remember this, x squared. Okay? Can you see? So, okay, let me say I want to find where x is equal to 1. When x is equal to 1, what will happen? When x is equal to 1, when my x is equal to 1, what is my y? I come here and say, okay, when my x is equal to 1, what is my y? My y, it is 1. 1 squared, it is 1. Okay. Let me come on this side. I want where x is equal to negative 1. Okay, negative 1. Okay, when x is equal to negative 1 now, what is my graph? My graph is going to be negative 1. So, this is negative 1 here. The x is negative, right? Sorry about that. Then here, the x is positive. It is okay. When you include negative 1, remember you're going to say negative 1 squared. You get positive 1. Then when you say x is equal to 1 squared, you get what? 1 again. So it means now it is 1 and 1. So I need to do what? To interchange those coordinates. This one was negative 1 and 1. So I'm going to do it what? 1 and negative 1. Where is 1? 1 is going to be now x. 1 and negative 1. Where is 1 and negative 1? 1, it is here, right? Where is negative 1? Negative 1, maybe it might be here. Okay? So this is my what? This is the point that I've done. Negative 1 and 1. Then I'm changing this point again. This point, it is 1 and 1. Can you see? Even if I change it, it is 1 and 1. So it means here I'm going to have that, this point, the same there as 1 and 1. Okay, so how am I going to draw that graph? I'm going to follow the same parabolic shape. I'm going to follow the same parabolic shape, but now in that direction, like that. How interesting is that? Remember, this point is just a common point. 1 and 1. How interesting is that? Very interesting, isn't it? So now where is my line is equal to y is equal to x is going to sit? The line y is equal to x is going to sit. Remember, it sits exactly from the origin. Okay, let me redraw that. It's going to be exactly from the origin. From the origin, like that. Ooh! So this is my line y is equal to x. So this is my what? My graph of f. This is my graph of my inverse. The question is my inverse a function or not a function? That is the question. Is my inverse a function or not a function? Okay. When we check my inverse, when I do a vertical line test, just a vertical line test anywhere on my graph, can you see it touches my graph? I mean, here and here. So it touches my graph twice. So does that mean what? Is it a function? No. It tells me that my inverse, it is not a what? A function. Okay. Remember, now I'm trying to deal with everything that is a function. So now what is it that I'm going to do? What is it that I'm going to do now such that this one becomes a function? Okay. Okay. What I can do is I can say, okay, this one becomes a function if it touches this point. So if I can remove this portion of the graph, it can become a function, okay? Or if I remove this portion of the graph, it becomes a function because it touches once there, okay? Let me just do this practical. If I remove this portion of the graph, can you see now this becomes my what? My function, okay? Or if I remove this part of the graph, can you see my inverse becomes a function, okay? So how can we do that? What I can do is now restrict, okay? Now we call what? A restriction, okay? We call it a restriction. Okay, now restriction now we can apply usually because we don't know something. So where do your restriction enter now? to answer my question, we're gonna now talk about what? Restriction. Here, what is a restriction now? So a restriction, it is basically me restricting what? The original function. Okay? This will be me doing what? Saying, okay, I need to restrict my original function. Which one is my original function? My f graph, such that now I need only one portion of it. Why do I need only one portion of it? Because if I have only one portion of it, I'm going to draw this point. Can you see -1 and translate that is going to be 1? Here, I'm sorry about this one. Remember, we translated this point to what? 1 and -1. 1 and -1. So, can you see, if I just have this portion, when I draw its inverse, it's going to be just this portion where I have translated that. And can you see, when I do that, the graph now, this one no longer exists. This one no longer exists. It now means now this one will have a what? It will now be a what? A function. Why? Because now it touches the graph once. I'm talking about the yellow part of the red part. Okay? Oh, okay. So how can I restrict that? I can restrict that by saying, okay, if my x values are less than negative, so if my values are less than 0, okay, if my values are less than 0, can you see, from 0 to that part, to the negative side, I'm going to have an inverse that is what? Is a function. Okay, so it means the first restriction on f of x is equal to x squared. It is now I need my x to be less or equal to 0. Less or equal to 0. When it is that, it means I'm gonna only draw this portion of the graph. Only this portion of the graph. Why am I not including this one? This one. Because now the restriction says to me specifically it needs on the domain, I need it on the domain where x is less or equal to 0. Remember the domain of f of x originally. It is x is an element of real numbers from -infinity to infinity. The domain of x squared. Hence now we are drawing from -infinity here to what? To positive infinity. But now specifically the examiner says now I need it to be from negative less than 0. This is the same as saying x should be between -infinity to 0. Okay, this is the same thing. Okay, so now the examiner says I need you to draw this graph of x squared from this portion of what? Of negative x to 0. Let me do that. Let me draw an x squared so that I show this nicely. Okay, so that I show this nicely. When I do that, I'm gonna have part like this. I'm gonna say, okay, this will be my, remember, I'm start first by drawing the full shape, x squared. The x squared, you know, it is this part, that part. But the examiner wants it from where it is less than 0. Less than 0 starts from here going to the negative. Can you see less than? It goes to that side. So, okay, what does this mean? It means now I need to erase a part that I don't need. Which one is that? The 1. Okay, so this is me drawing f of x when x, so f of x is equal to x squared when x is less than 0. Okay, so now it means now, remember, what did we get for the inverse? Remember, for this equation, you get an inverse is equal to what? Our inverse was equal to what? Plus or minus what? Square root of x. Oh, okay. Remember the domain here was now x should be greater or equal to 0. This one, it tells you, okay, the domain, it should be x is greater than or equal to 0. This is just the domain, okay? So now, this one is the inverse of f of x is equal to x squared, okay? But now that I have x squared minus is less than 0, so it means here I need my y to be less or equal to 0. Remember, because whatever here you have you need to translate that there, but now in terms of y, okay? So how can you do that? How can I make now y be less or equal to 0? It is me now coming to this portion and saying, okay, if I want my y to be less or equal to 0, it means I need to take negative portion of this. If I take that one to be negative, can you see it's going to be negative square root of x? Even if I say negative square root of 1, it's going to be negative 1. Okay, not square root of negative 1. Negative square root of 1 is going to be negative 1. So, oh, okay. So it means now the inverse of this one, okay? The inverse of this one is going to be what? Negative square root of what? Of x. No longer plus or minus. Oh, so if this one is less than 0, I'm taking the negative. Okay, so if it is greater than 0, what will happen? We'll come to that. We're going to say, okay, if it is restricted like this, it's going to be this one. Okay, you can also include that x. This x does not show this x here. It has nothing to do with this x. It just tells you about the restriction, where now this x inside the bracket here needs to be positive, and for it to be positive, it needs to be what? To be greater or equal to 0. But now when we draw, just find any point here, okay? Just use negative 1 and 1. Remember, it's going to be what? 1 and 1. 1 and, sorry, negative 1. Sorry, 1 and negative. Okay. This point here, it is negative 1 and 1. So it means that point is going to be 1 and negative 1, okay? So when it becomes 1 and negative 1, it's going to give you a graph that looks something like that, okay? That looks something like that. Remember the full portion of this, it is what? It is that. The full portion of this one, it is what? It is that. But remember, I want where x is less than 0. So I'm removing this. Also here, I want where x is Zhuang, y is Zhuang. Remember, this is y. Y is equal to something. This is y. Where y is negative. Y is negative. Here it is positive and negative. So it means I need to remove this. I need the negative part. How interesting is that? So how do you restrict this? This is by restriction when you restrict x to be less than 0. This is what we refer to as the restriction. But now, okay, what if the examiner comes to me and say, instead of us restricting that on x is less or equal to 0, how can the examiner restrict this to f of x, the same function x squared, but now restrict it to where it is greater or equal to 0? Yes, the examiner can fully be in a position of doing that. What do you mean now? I mean now the examiner can say, here it's either you draw it or the examiner has already given you. Okay? Remember the full portion of this, it is what? It is this. It is this. It is also that, right? This is the full x squared. But now the examiner where x is greater or equal to 0. Where x is equal to 0 here, greater means that side. Greater means you go that side. So this is greater. So the examiner only wants the green part. So what am I going to do? Erase this one. Okay? So I'm left with this one. Okay? Remember the restriction, it is x is greater or equal to 0. Okay? Then now, where can I draw now? How can I draw the inverse of this? Remember the inverse of this, the full part was this again. Okay, the full part was that, right? But now the examiner wants it where? So it means now the equation of the inverse on this one is going to be, the inverse is going to be, remember it is plus or minus square root of x, but now the examiner wants it where it is greater than 0, meaning it is positive, like this here. So it means for this one, we're going to use positive what? Positive square root of x. You don't need to include that positive, but it's fine. You can just put it there, okay? Okay? So we do what? This means now our y values are positive. Okay, because positive or square root of 2, it is positive square root. So it means now our y values here are positive. Okay, so remember here the y values were less than 0. Okay, if you follow this, it tells us the y values are less than 0. Here, the y values are less than 0 and negative here. But here, it is greater than 0, meaning our y values need to be greater or equal to 0. Okay, so greater means positive like that. Okay, so it means I need to remove this one. How interesting is that? So now this is a what? A point of contact there of here. Okay, yes. Okay, yes. Like that. So here we restricted when x is greater than 0. This is also a restriction. Why? What is the purpose of us restricting this function? It is because now the original inverse function, which is this one here, it is not a function. So we need to restrict the domain of our original such that this one becomes a what? Becomes a function. Oh, okay. What if now we have this? Because now we get that left. What if we have this? What if we have this? F of x is equal to negative x squared. Hey, go towards. Then when x is less than 0, you can't be using positive x squared. I want to know. Remember, I tried to give you all the possible questions that they might come again. So you're gonna say on this one, okay, fine. How do you find the inverse? Just change this one. You'll just say it will become x it is equal to negative y squared again. Remember, you're going to divide by negative. It's going to be negative x is equal to y squared. Then when you square this, you square this. Remember what comes here. It's going to be plus or minus square root of negative x. It's fine. The negative is fine. You're not solving for now. Okay? So it means this one is going to be y is equal to plus or minus. Remember that plus or minus is always there. Negative x. Okay? Oh, so it means the inverse of this one, it is what? Plus or minus, it is always there. But in this case, it's going to be what? Negative x. So now, what is supposed to happen? Remember, inside the square root, you're not supposed to have a negative number. So it means now we need our x to be less than or equal to 0. What do I mean? I repeat, I did this example here. I'm saying if you have negative x here, just substitute x as anything less than 0 or equal to 0. Let's check. When x is equal to 0, it's going to be negative 0. It is also equal to 0. Cool. Negative, when I put negative, x as negative 1, it gives me 1. Okay, but what if I put x as positive? It's going to be undefined, no solution. So it means I need my x here to be what? To be less or equal to 0. Okay, sharp. It's fine. I cannot write it. I can just ignore it for now, okay? And say, okay, remember the restriction says now less than 0. So if it is less than 0, I know my inverse. Now I know again. Now I know. Let us draw first, okay? When I draw this one, remember, negative x squared, it is set again. Negative x squared, it is set like that. So when it is set like this, but the examiner says to me, I need it to be less than 0. X should be less than 0 when I draw. X is less than 0. Okay, this is 0. Less than 0, I go to that side. So it means I need to draw for this portion only, meaning I erase this. Oh, okay. Before I do that, I need to see how is my inverse. Remember when we had this part, the inverse was like this, okay? So it means when I have that part, my inverse will look the other way around, okay? So instead of my inverse looking this way, like it did there, it's gonna look the other way around, okay? So if this one was looking up, that one looked to the right, okay? Up, right, okay? So now if you're looking down, you need to look to the left, like that. Up, right, left, down, shake, like that, right? So it's gonna be now, okay. It means this one needs to be like, okay. Sorry about that. Like this, something like that, maybe. Okay. Sorry. Like that and like that. Okay. Oh, let me use a different color. So this needs to be that. This is my original again. I'm just drawing my F, my full F, and my full inverse. Then I come back, okay. Remember I drawing using a pencil, so anything is gonna be cool. The examiner said now to us, I need this to be on x is less than 0. X is less than 0, meaning now I need only this portion on the F graph, okay? So it means I need to pressure off this one. When I do that, okay, sharp. So it means here, remember x, when it comes here, is going to be y is less or equal to 0. So, okay, where is y less or equal to 0? I need to say, oh, okay, so y is less or equal to 0. It means here I need to remove this minus, this plus or minus, and say, okay, this should be negative. Why? Because now my x are negative, then therefore that need to be negative. Also remember, see here, they said less or equal to 0. Then y, when it's less or equal to 0, instead of writing less, y is equal to less or equal to 0, we are now choosing it by taking the negative sign in front thereof. Okay. So similarly here, instead of saying y should be less or equal to 0, we're gonna instead do what? We're going to instead say x should be less or equal to 0. Then y is less or equal to 0. I'm going to choose from the plus or minus. The plus or minus, I'm going to choose the negative such that the y becomes negative. Oh, okay. That's so clever of you. Then where is our y negative? Remember here at the top it is positive, at the bottom is negative. So it means now I'm going to need this part where the y are negative. Can you see those? The y are negative. And also remember the restriction here. The restriction tells you that x should be less or equal to 0. This is not necessarily the restriction. This is the domain, okay? Yes. So, but it's fine. Remember, the y should be negative. The y are negative where? On this portion, red graph. So it means I need to remove this. Can you see now I have my part? This is my f. Okay, let me rewrite that. This is my f. This is my inverse. Okay. Similarly, here I had my inverse. Then I had my f. Then I had my f. Then, okay, this is the equation for that one then, I guess. Okay, yes. So now what if the examiner says to me, okay, I'm giving you f of x, it is equal to negative x squared, but now I'm changing your restriction to greater or equal to 0. Okay, I'm changing your restriction to greater or equal to 0. So what will happen? What will happen? I'm going to say, okay, examiner, you think you're smart. Well, you're not. Okay, well, you're not. I'm going to have this. I'm going to have this. Okay. And since well, the examiner has restricted now my from greater or equal to 0, I already know my inverse should be something like, my inverse should be something like, let me do this. My inverse should be, instead of negative, since well, this is a greater, it should be now plus what? Square root of negative x. Negative x, okay. Even if you do not write this plus, it's fine. You don't need to write this plus, okay? But I'll just write it for the purpose of just explanation. Then you can do what? Draw your full f of x, okay? When I draw my full f of x, remember it is negative like that. It's going to be something like so. Okay? Okay, I think I messed up. Yeah. It's going to be something like that, okay? Yo, okay? This is your f of x, right? But negative x squared, right? So my the examiner wants it to be x to be greater than 0. X here are positive, greater than 0 here are negative. So I'm going to only choose this portion. Why this portion? Because x here it is 0 and going to that right, it is positive. Here was negative, I took this portion there. Okay. Then how was my inverse looking? My inverse was looking something like this. You still remember that? You still remember that? But the examiner wants that to be where? My examiner wants that to be where now, remember for my inverse, greater than 0 means my examiner wants it where it is positive. Where is it positive? I'm talking about the y values here. Remember here, we said we want where on the f, we want where x are less than 0. Okay? X is less than 0. So it means on the y, we want where y are less than 0. So, okay, that's how we are checking. That's how we are checking it. Here, we wanted where y are greater than 0, x are greater than 0, meaning on f, where x are greater than 0, but it means on the inverse, we are looking where y is equal to 0. Can you see now here, the x are positive, are positive, are positive. That satisfies this. But we need for the inverse, the y to be positive, 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 like that. Okay, yes. Here, why is it vice versa? The examiner wanted where x are negative, negative, negative. So it means on the inverse, the y, we need them to be negative, negative. Why negative, negative? Is it yes? Yes. So similarly here, the examiner want y x are greater than 0 again. X is greater than 0 for the original f of x is k sharp. Then for the inverse, it needs now my y to be greater than 0, positive. Where is that? These are positive, these are negative. So it means I need to take off this part. So can you see now what I have? This is my inverse, just like that. And its equation, it is given to me as that my y's are positive. My y's are negative. Is it true? Yes. Can you see now? Yes. That's the summary of that. That's the summary of that. So the examiner, they can ask you, how can we restrict the domain of f such that its inverse becomes a function? You just say x should be greater or equal to 0, or x should be less or equal to 0. These here, okay, let me write them here. These here, okay, I don't have enough space. Let me take this here. Okay. These two here, whether x is less or equal to 0 or x is greater or equal to 0, that is what I refer to as my what? These are my restrictions. These are my restrictions. So I can either man, you need a highlighter here, Lisa. I can either do what? Restrict it to where x is less or equal to 0, or I can restrict it to where x is greater or equal to 0. Especially when the examiner asks you, how can you restrict that? You can say x is less or equal to 0, or x is greater or equal to 0. You can write them both, you can write one, it's fine. Okay, but the examiner, if the examiner has already drawn you a graph, then it's fine. You will be in a position of understanding. Then the examiner might say to you, this is point P of coordinates. Let me reduce this. This is point P of coordinates -6 and 8. What are the coordinates of R? Okay. What are the coordinates of R? The reflection, remember R, it is the reflection of P in the line X, Y is equal to X. Okay. The examiner will tell you R is the reflection of P in the line Y, it is equal to Y is equal to X. Okay. So what is the coordinate of R? Remember here, what I have here, what I'll have there, it is the swap. I'll just have swap around of it. What is that? What do you mean swap around? I mean now, you need to interchange this one. If this one is -6 and 8, it means on R is going to be what? R is going to be 8 and -6. Very, very true. Remember where they meet, they share the same coordinate. Does these two meet? Where do these two meet? I mean, the English partner. These two meet at the origin at 0 and 0, and there they share the same coordinate. Can you see that? Yes. These ones, where do they meet? They meet at this point. So whatever this point it is here, maybe if at that point it is 6 and 8, then it is common for both of them. This one, it is also common for them. It is 0 and 0. Can you see that? Yes. Okay, this is very, very nice. Then it means here, they also have the same coordinate. If this is -6, this is -8. Y is negative, Y is negative. It is the same. Also here, it is 0 and 0. So it means this one, this point here, if it is P, it is negative what? -6 and 8 again. So it means any point here which is R, it is how much? 8 and -6. They'll tell you, even if they do not say this is R, they'll say R is, okay, they'll just put R and tell you R is a point on F such that R is a point on graph F such that it is obtained when the coordinate P, it is now It is now what transformed, translated. We have I want this word when it is. We have transformed. We have the word is gone. The word is gone, and I wrote it somewhere at the top when we started. Reflect. When I reflected across the line, y is equal to x, right? Yes. Even if they did not put this point exactly here, they might say to you, they might say to you, more into the master. They might say to you, okay, we have a point here of coordinates. Okay, I need to reduce this. We have a point there of coordinates -1 and 2. This is okay, I do not have enough space. I come back. Let's say they have this point it is M with coordinates -1 and 2. They say now find this point here. Okay, that point it is N, and it is a reflection of M in the line y is equal to x. So how can I see that? How do I know this point? I do not need to calculate it. They will just say, write down. Okay, write down meaning you can do that by inspection. I'm going to say, okay, if N is a reflection of M across the line y is equal to x, it means now I need to swap x and y of M. So it means for N, I'm going to have 2 and -1. Here, this doesn't make sense. -1 and -2. Okay, the y are -2 are negative in this side. So it's going to be -2 and -1. Okay, yes, basically that. Okay, basically that. If, okay, yeah, just, I think this is it. This is already a long video. This is already enough for you for inverse function. They do not worth much marks. You can get something like maybe 8 marks, sometimes 6 or what. But this is basically that for the inverse function. So thank you very much, folks. I hope and I believe that you having me today under inverse functions, you learned a lot, and now you're in a position of answering and knowing whether a function it is a graph it is a function or not. So thank you very much, folks. I hope you had a great stay with me on this video. Let's meet on the next video. Thank you very much.